teach you the applications of second order linear differential equation. According to VTU syllabus, we have got two applications of second order linear differential equation. The first one is LCR circuits and the second one is vibration of string. Today, I am going to teach you how to solve the LCR circuit when some data and initial conditions are given. Before starting the problems, let me learn first what is LCR circuit. About LCR circuit, you have studied about LCR circuit in electrical and physics. First, what is LCR circuit? Any electrical circuit containing a resistor R, an inductor or inductance L, and a capacitor C as shown in the figure are called the LCR circuit. The current I in the circuit at time t is governed by the first order linear differential equation L into di by dt plus Ri plus Q by C is equal to E, where I is the current. The relation between the current I and the charge Q is given by I is equal to dq by dt. Here, E is the EMF. Hence, equation number 1 will be changed to the second order linear differential equation after substituting I is equal to dq by dt, that is L into d square q by dt square plus R into dq by dt plus q by C is equal to E. This is the second order linear differential equations which consist of the inductance L, R the resistor, C the capacitance, E the EMF, Q the charge. The relation between the Q charge and I current is I is equal to dq by dt. Let me move on to the problems. The first problem. Find the charge on the capacitor in an LRC circuit where L is equal to 5 by 3 Henry, R is equal to 10 ohms, C is equal to 1 by 30 farad, and E of t is 300 volts. Assume the initial charge on the capacitor is 0 coulomb and the initial current is 9 ampere. What happens to the charge on the capacitor over time? To solve any problems, first we should identify what are the data given. That is the first condition. Second one, what they have asked us to find. It's the second condition. And the third condition is to find what they have asked, which formula we have to use. Using these three conditions, I am going to solve these three problems. What is the given condition? Here, the condition is initial charge on the capacitor is 0 coulomb and the initial current is 9 ampere. Means charge, that is Q is equal to 0 and the current I is equal to 9 when T is equal to 0. That is the initial condition they have given. Data they have given, L is equal to 5 by 3, R is equal to 10, C is equal to 1 by 30, E is equal to 300. These are the data they have given. What they have asked us to find out? Charge on the capacitor. What is charge on the capacitor? Q. How to find out this Q? To find this Q, which formula we have to use? That is the differential equations of LCR circuit we have to use. What is the differential equations of LCR circuit? L into d square q by dt square plus R into dq by dt plus q by C is equal to E. This is the governing differential equations of LCR circuits, which I am keeping it as equation number 1. Now from the given data, the value of L, R, C and E, I am going to collect, I am going to substitute in equation number 1. So what is equation number 1 will be 5 by 3 d square q by dt square plus 10 dq by dt plus q by 1 by 30. 1 by 30 is a C value. It's equal to 300. Now take LCM this 3 and bringing the denominator 3 to the other side, we will obtain the equation as 5 capital D square Q plus 30 capital DQ plus 9Q is equal to 900. What is this capital D square capital D? I have written small d square Q by dt square as capital D square Q and dq by dt as capital DQ. Simplifying this, that is my first video I have explained. Now Take this q, the common one is outside, and divide throughout the term by 5 because 5 is a common factor of this equation. So we can divide throughout by 5. We will obtain the equation as d square plus 6d plus 18 of q is equal to 800, which is the second order linear differential equation, which we can solve and solution we can obtain. What is any general solution of a second order linear differential equation? The general solution is defined as complementary function plus particular integral. What is complementary function? To find the complementary function, first we should write the auxiliary equation. What is auxiliary equation? Replace d by m and remove the q. So what will you get? M square plus 6m plus 18 equal to 0. Solve this quadratic equation using your calculator or the normal formula method, minus b plus or minus root of b square minus 4ac divided by 2a. You will obtain the value of m is equal to minus 3 plus or minus 3i. What type of roots are this? It is complex root. This is of the form alpha plus or minus I beta, which is a complex root. If the roots are complex, how to write the complementary function? That is e power alpha x into c1 cos beta x plus c2 sin beta x. Here the value of alpha, that is real part, is minus 3, and beta, the imaginary part, is 3, and here the variable is time t. So instead of x, t, instead of alpha, minus 3, instead of beta, 3 I have substituted. We obtained the complementary function. Next we will move on to the particular integral. How to find out the particular integral? Write the differential operator 1 by d square plus 6d plus 18 of 180. 180 is a constant number. So the case 1 of the PI we have to apply. What is case 1? E power ax. Here exponential is not there. Means I have to write the constant as a constant into e power 0x. Here instead of x, t. So I am writing 180 as 180 into e power 0t. If it is e power ax, what we have to substitute? Put d is equal to 0. So by substituting d is equal to 0, we will obtain 180 by 18 is equal to 10. Hence, the general solution is the complementary function plus the particular integral, that is q is equal to e power minus 3t into c1 cos 3t plus c2 sin 3t plus 10. This I am keeping it as equation number 2. Now, I want to find the current. Why I have to find the current? Because the initial condition states that the charge q is 0 coulomb and the current I is 9 ampere. To find the current I have to use the relation I is equal to dq by dt. Means what I have to do? Differentiate the charge q with respect to t. This is uv because e power minus 3t is a function of t, and c1 cos 3t plus c2 sin 3t is again the function of t. So product rule have to use the product rule. We will obtain this equation, and the derivative of constant 10 is 0. Thus I have got the current I is equal to e power minus 3t into minus 3 c1 sin 3t plus 3 c2 cos 3t plus c1 cos 3t plus c2 sin 3t into minus 3 e power minus 3t. How I have obtained this? Derivative of e power minus 3t is minus 3 e power minus 3t. And derivative of cos 3t is minus 3 sin 3t, and derivative of sin 3t is 3 cos 3t. By substituting this value, I have obtained 3 equation. Now I am applying the condition. Initial charge on the capacitor is 0, means q is equal to 0 when t is equal to 0, and initial current is 9, means I is equal to 9 when t is equal to 0. Substitute these two conditions in equation number 2 and 3. We will obtain the value of c1 and c2. That is, c1 is minus 10 and c2 is minus 7. Substitute the initial condition, that is q is equal to 0, t is equal to 0 in equation number 2, and a is equal to 9 and t is equal to 0 in equation number 3. Solving will obtain the c1 and c2 as minus 10 and minus 3. Replace the value of c1 and c2 in equation number 2 to get the recovered charge on the capacitor. That is, q is equal to e power minus 3t into minus 10 cos 3t minus 7 sin 3t plus 10. We'll move on to the second problem. Same similar problem of the first I have taken by taking a small changes in the inductor, resistor, capacitor and E value. By taking a small change, I'm solving the second problem. Same, like there is not much change. What is that? What is second problem? Find the charge on the capacitor in an LRC circuit. Same, we have to find the value of Q given L, R, C and E. These 4 values they have given. Condition is assume the initial charge on the capacitor is 0 coulomb and the initial current is 4 ampere. The previous problem, Q is 0 and I is 9 when T is equal to 0. Here, Q is 0 and I is 4 when T is equal to 0. That's all the different. And the inductance, resistor and capacitor and the EMF value different they have substituted. To find the charge, I have to use the LCR circuit differential equation. What is that? L into d square Q by dt square plus Q into dQ by dt plus Q by C is equal to E. As usual, you keep it as equation number 1. Substitute the given values of L, R, C and E. By taking 5 as LCM here, we'll obtain the second order differential equation as d square plus 2d plus 10 of Q is equal to 250. Again, the general solution of the second order linear differential equation is complementary function plus the particular integral. To find the complementary function, first I should find the auxiliary equation, that is m square plus 2m plus 10 equal to 0, quadratic equation. Solve it, you will get the complex root minus 1 plus or minus 3i. This is of the form alpha plus or minus I beta. The complementary function is e power minus t into c1 cos 3t plus c2 sin 3t. Now the particular integral 1 by d square plus 2d plus 10 of 250. Again 250 is a constant. So to use the case 1 of particular integral, we want e power ax, here e power 0t, because constant part 250 can be written as 250 into e power 0t. If it is e power 0t, what value we have to substitute for d? D is equal to 0, you substitute, you will get 250 divided by 10, which is 25. Now we obtain the complementary function and the particular integral. Addition of these two will be the general solution. Hence we have obtained the general solution is Q is equal to hence we obtained the general solution is Q is equal to e power minus t into c1 cos 3t plus c2 sin 3t plus 25. Now, same like previous problem, I want to find out the current. That is, the relation between the current and the charge is I is equal to dq by dt. To find this, we want to differentiate q with respect to t. Similarly, e power minus t and c1 cos 3t plus c2 sin 3t, both are functions of t. Hence, the general solution is q is equal to e power minus t into c1 cos 3t plus c2 sin 3t plus 25. This is addition of the complementary function and the particular integral. Now, we need to find out the current. What is the relation between the current and the charge? I is equal to dq by dt. To find this, we want to differentiate q with respect to t. Again, I am going to use the product rule because e power minus t is a function of t and c1 cos 3t plus c2 sin 3t is also a function of t. So product rule I have used, we have obtained the equation 3. And what is the initial condition they have given? Initial charge on the capacitor is 0 and the initial current is 4, means Q equal to 0 and I is equal to 4 when T is equal to 0. If you will apply these two conditions in equation number 2 and 3, we will obtain the value of C1 and C2 as minus 25 and minus 7. Substitute the value of C1 as minus 25 and C2 as minus 7 in equation number 2 to obtain the charge on the capacitor. Let me move on to the third problem. An LRC circuit carries an EMF of voltage E is equal to E naught of 1 minus cos t. Find the charge and the current at time t greater than 0. Initially, there is no charge and current in the circuit, given that the value of L is equal to R is equal to C is equal to 1. As I have explained in the first problem of this LRC circuit, to solve any problem, first we should know that what data, whatever they have given. Second one, we should know to identify what they have asked us to find. Third one, to find that whatever they have asked, we need to apply some formula. What formula we have to apply, we should know that. So first, let me identify the data given. What are the data they have given? L is equal to R is equal to C is equal to 1. And E is equal to E naught into 1 minus cos t, which I am writing it. Now, what they have asked us to find out? Charge and the current. What formula we have to apply? Governing differential equation of LRC circuit. What is that? L into d square q by dt square plus R into dq by dt plus q by c is equal to E, the EMF. In that formula, you substitute the value of L, R, C as 1 and E as E naught into 1 minus cos t. We obtain the equation number 1 as d square plus d plus 1 of q is equal to E naught into 1 minus cos t. What is the solution of this equation number 1? Again, since we have got RHS, the solution of equation number 1 will be complementary function plus the particular integral. To find the complementary function, first we have to find out the auxiliary equation, that is m square plus m plus 1 equal to 0. Solve this quadratic equation, we'll obtain the root as minus half plus or minus I into root 3 by 2. This is of the form alpha plus or minus I beta, that is the complex root. So we can use the formula e power ax into c1 cos beta x plus c2 sin beta x. What is the value of alpha and beta here? Alpha is minus half and beta is root 3 by 2. Now, we'll find the particular integral. What is particular integral? 1 by d square plus d plus 1 of E naught into 1 minus cos t. E naught I am taking common outside. This 1 minus cos t, two different terms, I am going to separate this operator. That is 1 by d square plus d plus 1 of 1 and 1 by d square plus d plus 1 of cos t. Since 1 is a constant, constant can be written as e power 0t. How to substitute the value of e power 0t when the case is PI1? We have to substitute d is equal to 0. When you apply d is equal to 0, what you'll get for the first term? 0 plus 0 plus 1. That is 1 you will get. E power 0t is 1. Minus here cos t means PI second case. How to solve the particular integral when the case is second type? We have to substitute d square is equal to minus 1. When I substitute d square is minus 1, I'll get minus 1 plus d plus 1. Minus 1 and plus 1 will be cancelled. 1 by d means integration. What is integral of cos t? Sin t. Thus, we obtained the particular integral as E naught into 1 minus sin t. Thus, we obtained the complementary function and the particular integral, add both to get the general solution. Thus, we obtained the general solution is q is equal to e power minus half t of c1 cos root 3 by 2t plus c2 sin root 3 by 2t plus e naught into 1 minus sin t, which I am keeping it as equation number 2. Charge is known. How to find out current? I relation we know that is I is equal to dq by dt. Means I have to differentiate q with respect to t. Again uv product rule, that is e power minus half t into derivative of cos root 3 by 2t is minus root 3 by 2 c1 sin root 3 by 2t, and derivative of c2 sin root 3 by 2t is root 3 by 2 into c2 cos root 3 by 2t. And what is derivative of e power minus half t? Minus half into e power minus half t. Thus, we obtained the I value as equation number 3. What is the initial condition given? Initially, there is no charge and current. Means Q equal to 0 and I value equal to 0 when T is equal to 0. So substitute this in equation number 2 and 3. We'll obtain C1 as minus E naught and C2 as E naught by root 3. Substitute the value of C1 and C2 in equation number 2 and 3. We'll obtain the charge and the current.